Alright kids, so today we're going to talk about energy diagrams, and this should be a nice little revision before we go into our exams. Now, you'll notice a slightly different format, Comic Sans and all sorts of horrible stuff's happening, and that's because, well, to save time, I've pilfered this from someone else. Alright, so let's go. Now, just a quick reminder on rates of reaction. Basically, when chemical reactions occur, different atoms and molecules collide. That's called collision theory, and we see one, we go forward, bang, they hit each other and they combine. Now, for the reaction to happen, it needs to have what we call the activation energy, which is enough energy when they collide for reaction to occur. All right, there are several things that can deal with that and increase it, blah, blah, blah. Now, exothermic and endothermic reactions, basically, whenever a chemical reaction happens, energy will be supplied and it will be released. Now, an exothermic one is where there's more released than supplied. Endothermic is when there is more supplied than is released, and the temperature for an exothermic one, the amount of energy decreases of the molecules, and the amount of energy of the molecules increases for endothermic. Now, when we talk about delta H, by the way, delta H, we are talking about the potential chemical energy of a substance. All right, so here we go. The reaction starts and it moves forward. It hits the activation energy, so you have to put a little bit of energy to make it go react in the first place, and then we see that it drops down, which means that the bonds have released energy as they've formed new bonds, and this is an exothermic reaction. So we've got the activation energy and the energy given out. So here's the activation energy is going along, we put the energy in there, and we need a better pen than this. So it goes along and your energy goes up, you supply a bit of energy to make it happen, and then it uses that and then a bit more, or releases that energy. Alright, so if we use a catalyst, what actually happens is it will go along and decrease. Take notes on this. This isn't, the catalyst section is not important for the exam, but it is important for later on, so we'll do it now. Alright, so exothermic versus endothermic. Basically, an exothermic reaction is one where there is less energy at the end than there is at the beginning. Okay, so more energy is given out than is taken. An endothermic one has a reaction that goes along and it absorbs energy in. So more is taken in than is given out. Alright, we can have a look at the different types and we can work out which one is more endothermic and which one is more exothermic. And it's all to do with the gap. And that gap, by the way, that is delta H. And here's the gap. It goes between there and that is delta H. Okay, so here's an extremely exothermic and here is a moderately exothermic. And here's an extremely endothermic and here's a moderately endothermic. You can see there that delta H is much smaller there than it is there. Alright, so basically here we've got a small activation energy with no net energy change. In other words, it's neither exothermic nor endothermic, it's equal on both sides. And here we have an endothermic reaction as it goes along, and here we have, and the activation energy is there, but it's just not being shown, so it would actually look a bit like that. And we say same here, there's just not showing the activation energy. Now, that's it. I hope that was helpful, and yeah, we'll see you in class.